We'll now hear from our first partner of the day, Vikram Mahidhar from Rage Frameworks. Welcome, Vikram.
Good afternoon. So we heard from John and Joaquin that AI is very difficult to bring into workflow. And one big reason for that is context. And that is a problem that we have solved and we continue to solve in other use cases that we've not addressed yet. So when you think about Rage, first of all, sort of, many of you may not have heard about Rage, so let me just explain who we are. We are an AI-based automation platform, and we automate business and knowledge processes in a variety of different industries. We are a 500 people company. We've been around for 7 years and growing very rapidly. Now, through my talk, I will explain a little bit more as to what exactly do we do as we go out and implement our platform. Three things to think about when you think about Rage: context, simplify, and speed. That's what I would leave you with. Now, the reason why I'm here is I wanted to share some of our learning through this journey over the last 7 years. We think that enterprises are at the cusp of re-architecting their business models. If you think about enterprise architecture, if you think about design, build, and execute, the build and execute part is being completely taken over by machines. And I'll explain how. And that's where we started Rage. 7 years ago, we started with a vision that why can't you take the business process, any business process or a knowledge process, and why can't you completely automate that? Leave the execution to the machines. Second, when it comes to build, why can't we even do the build part very rapidly without writing much of a code or no code over and over? And most importantly, how can we build those applications in the context of a particular business process? Because today, what happens, and I'm pretty sure that this will resonate with most of you who operate in the industry, is say you want to automate a customer-facing process. First thing, you go buy some sort of a packaged software, bring it in-house, do an open heart surgery on that software, throw the half of the software out, build wrappers after wrappers after wrappers. You're done, $10 million in, and then next year you come back, and then somebody says, oh, new feature, $2 million. Does that resonate? It does, see? So the point I'm trying to make is how can you really build any kind of a application and wrap it around your business process and keep changing it as the context changes without going through the scenario that I described. That's what we have built. What you see on the screen here is what we've done is we've built 20 different engines. We've abstracted those engines enough that by and large, we can pretty much build application to automate any business process or any knowledge process in days, weeks, not years or months. To give you an example, one of our clients, one of the top 3 commercial lending companies in the country, we created end-to-end commercial lending platform for them in 77 days. And when I say end-to-end commercial lending, simply said, the way we do it, the way the lending process works is first you prospect. You send a whole bunch of emails to the prospects. Some of the prospects latch on. They say, yes, I want to apply for the loan. They submit all kinds of information, their financials in PDF, their electric bills, and variety of different other financial statements. Machine takes that all in and interprets that information, and based on whatever information that is not available, creates a set of questions and says, oh, by the way, here are the questions that were not answered based on the information that you provided. Will you please enter that? Answers come in, they go into some sort of a risk model and goes to the underwriter. If all the criteria are met, you get the decision within 60 seconds that your loan has been approved or declined. It's two things. One, this entire application was built in 77 days. And second, the contextual intelligence here, end-to-end, whatever is being fed to the machine is interpreting that, bringing it in, and I'll talk about the contextual intelligence in a minute as to what we have done there, what's our invention there. And it is being executed, and the whole execution is happening in 60 seconds. No human being involved. Obviously, exceptions are there. For exception management, there are always human beings, at least at this stage, and so on and so forth. Now, the second thing here, when I talked about flexibility, what we are doing is very successful launch in the United States. Let's go to Australia. Let's go to Germany. Every 2 weeks, these 20 engines that you see, we have used them to configure the entire application. We are just changing the configuration. And what happens is that it is at the level of abstraction where technically a piece of software is a data model for us. And now, when any user is touching any screen, that is being recorded as data. That has been recorded as context, and machine learns from that data. And any processing that is happening, it is continuously learning from how the exception handlers are handling certain exceptions. Next time, that exception will not show up as an exception. It will be straight through processing. That's the build part and some of the execution part. That's our first invention, if you may. The second piece is we talked a lot about context. Gary, many other people talked about it. What we have done is we have taken a language-based construct for machine learning. So we have built our engines to learn based on the language construct. There are 16 different dimensions to language construct, right from the way we express facts, we express causality, we express elaboration, temporal dimension, and many other aspects in the way we write business language, not Facebook language, business language. And what we have done is we have built the engines to learn on the basis of language. So we make relationships between subject, object, verb. Like for example, the word rose. If there's a word rose in an article or in a contract or what have you, what does that really mean? It could be noun, it could be verb, it could be many different things. So it is understood in the context because we are building it bottom up based on the construct of language. And the most important thing is that gives you a lot of speed because I don't need millions of documents to train my machine. Okay? Now, let me give you 2 examples of how are we really sort of creating business value, if you may, or what's the sort of what's the big deal here? A retailer came to us and said, we spend $1 billion on transportation. Transporters send us all these invoices, 100,000 plus invoices that are more complicated than the telephone bill. This surcharge, that surcharge, all kinds of charges on that. Oh, by the way, we think that the 35,000 contracts that we have across the country, those contracts are so subjective to each region, to each transporter, that there's no way we can match the two, but we do think that they're not billing us for the contract. Great. Oh, by the way, also the execution system. In execution system, it says, the transporter made three drops, but we've been charged for 5 drops. But that happens across 100,000 different invoices. And finally, our CFO takes $1 billion based on the execution data, puts it aside, and every year, we transportation division gets beaten up because there has been overbilling. Can you help solve this problem? It's a pretty meaty problem. And what we did using these 20 engines was in 8 weeks, we built the end-to-end application, sucked in the data from 35 different distribution centers, multiple different systems, brought in all that information, trained the machines to read the contracts using our linguistics-based machine learning, and I'll tell you in a second why that is important, and reconciled and read through all the invoices and created an automated reconciliation or cost audit system, what we call, which is giving them constant alerts, insights, and analysis on overbilling, underbilling, how should they standardize their contracts and whatnot, resulting into potential $40 million in savings. This is happening on a continuous basis. Now, the reason why the contextual machine learning or the language-based machine learning is important is because first sentence in the contract says, party A will pay party B such and such amount for this contract. As you go down, the terms and conditions are all very subjective. It talks about, oh, by the way, there will be a 10% kicker once you hit a certain number of loads in your delivery. And by the way, somewhere else, it says the 10% kicker will be divided based on these 3 slabs, and so on and so forth. If it is not contextual learning, then the machine will not know where to associate that 10% kicker to. Who's going to pay who? How do I calculate the amount, whether amount A is going to party A or party B? That's where, when the language-based learning comes in, the machine makes the relationships and associates right items with right parties, if you may. That's just one example. Second example, completely different example, risk management. Very important area, managing supplier risks, customer risks, market risk. And these problems can wipe out an entire company if it's not managed well, as most of us know. However, in case of, say, supplier risk, when I go and talk to many of my customers or prospects, if you may, and I say that, hey, how do you really manage the supplier risk? And I'm told that, look, we do obviously the credit checks, we monitor all the financials, we have very nice, financial models that tell you the risk of default, and Google Alerts. Google Alerts is a fine technology, but Google Alert does not understand your context. Google Alert does not understand what industry matters to you, what specific sources of information really matter to you. And interpretation of that information is also important, because I ask them, so what do you do with Google Alerts? Oh, I get so many of them, half of them are not relevant to me, and half are, but I don't have bandwidth to review everything, so we just look at some, headlines that look very scary, and then we work with them. These are real stories. So what we have done is we have curated 100,000 plus sources of information, paid, unpaid sources of information. We have trained engines across 90 different industries and created causal ontologies to understand and interpret that information, so that as the information comes in, first and foremost, it is understood in the context of a particular company. For example, if it is McDonald's, we understand that if we are commodity cost is one of the biggest risk drivers for McDonald's. But in case of McDonald's, oil, metal, gold doesn't matter that much as prices of livestock, vegetables, milk, and so on and so forth. So the machine has been trained to understand that context. Second piece is, as the information comes in, the machine understands that this is about livestock prices, for instance, and say there's a sentence in an article which says that chicken prices are getting stronger every day, killing beef with prices. Chicken prices are getting stronger every day, killing beef with prices. It's a complex sentence, but machine makes the correlation that this article is about chicken and beef, and chicken is not killing beef. Chicken prices are killing beef prices. It makes a relationship between killing and prices. And oh, by the way, the intensity of the word killing is very high. So this must be pretty dramatic impact on the prices. So this is negative in context of McDonald's. Oh, by the way, it's not just negative. After reading through the lines of different lines that follow up, the 16 different dimensions that I was talking about, now what you're seeing is there's a description after that says that in Q4 of 2016, it seems like the beef prices are going to mellow down. So there's a hope that the prices are going to get better. So the risk may be not that high. So let's adjust that negativity on a spectrum, and so on and so forth. And once that's understood, we send a signal to our to our customers that, hey, you know, if McDonald's is a company that you're tracking and you've given credit to them, or if they are, McDonald's may be probably not a supplier to anybody, but if they are one of the companies that matter to you from the risk standpoint, whether you are a supplier to them or you are, you know, you're their customer, whatever it is, you now get contextual early warning signals between the two financials, if you may, or financial disclosures, if you may. And that's all happening in the context. So like this, we have solved many different business processes, if you may, in the enterprise. And the key thing is, as you're seeing here on the screen, that, you know, better, faster, cheaper, flexible, speed to market, you don't have to choose from these different dimensions. It's all and. Let's see what we can make happen. That's where the industry is moving. That's what we see from where we sit. And we think that enterprise re-architecting this is the beginning of enterprise re-architecting. So with that, thank you, and much appreciate your time this afternoon.
Thank you, Vikram. Just one quick question. We've been talking for the last 2 days about the application of AI to enterprises. What's the most surprising or weirdest application you've seen in your work?
Surprising.
Well, I'll make it easy. The most creative application that you've seen of AI to the enterprise.
So I would say creative and surprising. I'll give you both, and surprise on both sides, actually. So this last example that I was giving to you about tracking 100,000 different sources, millions of pieces of information every day, interpreting and creating signals, and hedge funds and asset managers are also our clients who get these signals, and in fact we bring specific signals to them to trade stocks on. The surprising piece is that they find it scary. They say that, oh, all my life I've been thinking that market absorbs these signals very efficiently. But at the same time, as they begin to use it, they realize that there's so much inefficiency in the market, and they've been able to harness through AI. So creative, surprising, and effective.
Thank you very much, Vikram. I enjoyed that. Thank you.